Hearty welcome to the video series on questions for revision. Questions discussed at this video, topics from application of integral and differential equation. Reference material in all chapters of class 10 is available easily to all the students, but the students are not able to gather necessary help from these material as students need detailed explanation of the solution steps, recollection of the concepts required for the solution, tips to do problems and tips to reduce errors. The above needs of the students is taken care of at this tutorial series. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 10 questions from selected topic is compiled and the answers to the compiled 10 questions is presented in PDF and video format. Students are instructed to start your revision by downloading the file with questions for revision, and kindly note this material is only a supplementary to the revision strategies planned and executed by your experienced teacher. And move on to question number 1. The area bounded by the curve y is equal to root 9 minus x square included between the lines x is equal to 0 and x is equal to 3. X is equal to 0 is the y axis and x is equal to 3 is a line parallel to y axis. And what is this y is equal to 9 minus x square? It is the circle x square plus y square is equal to 9. It's a diagram for it. A circle centered at the origin and having radius 3. For what will be the required area now? Integral 0 to 3 root 9 minus x square. We have to use the formula root a square minus x square. It's one of the important formulae because this formulae is useful in circle and ellipse. Root a square minus x square dx is x by 2 root a square minus x square plus a square by 2 into sine inverse x by a. Have I applied it? Now I will apply 3 now. Wherever x comes minus, wherever x comes put 0. Now very quickly you can see that 0 into something and sine 0 is 0. Therefore the final answer 9 by 2 sine inverse 1. 9 by 2 into pi by 2. The answer 9 pi by 4. Kindly note down the steps in MCQ because these questions can be asked in 2 marks also. Go to question number 2. The area of the region bounded by the curve y is equal to x square and the line y is equal to 16. This is a parabola, upward parabola, and the line is a line parallel to x-axis. Let us see the diagram of it. This is the diagram. And we are having the area in both the sides. Therefore, the area will be 2 times 0 to 16 of y dy. And required area is x dy, and we have to find what is that x. It is root of y into dy, that is 2 into y power 3 by 2 by 3 by 2. You have to apply y is equal to 16. 16 power 3 by 2 is 64 and it is 256 by 3. Therefore required area is 256 by 3 square units. Question number 3. If m and n are the order and degree of the differential equation, then m plus n is equal to. Always remember, when a differential equation given like this, you have to convert it into a perfect equation, which is a polynomial equation in derivatives. Then only you have to find out what is its order and degree. Therefore, first let us find d by dx of dy by dx whole power 4. But it will be 4 into dy by dx the whole cube into d by dx of dy by dx by making use of chain rule. This is the final differential equation from where I have to calculate the order and degree. Which is the highest order derivative here? 2. Therefore, its order is 2. Its power is 1. Therefore, its degree is 1. But don't get directly tempted to write the answer as 1 and 4. Okay. Therefore, the answer is 3. M plus n is equal to 3. Question number 4. integrating factor of the differential equation dy by dx into x log x plus y is equal to 2 log x. This is a linear differential equation. Therefore, we have to convert it into a standard form. Divide throughout by x log x, because in the standard form the coefficient of dy by dx should be 1. Dy by dx plus py is equal to q. That is the format. Now tell me what is p here. P is 1 by log x, 1 by x log x, and q is 2 by x. For this linear differential equation, what is integrating factor? E power integral p dx. Therefore, e power integral 1 by x log x into dx. Therefore, u is equal to log x, and I am doing du is equal to dx by x. When I integrate, it is e power integral du by u over e power integral log u. Therefore, integrating factor is e power log of log x. You can do directly also, because the integral contains the differentiation of log x. Therefore, it is log x. Anyway, what is e power log of log x? It is log x. Let's move on to question number 5. Find the area of the region bounded by the parabola and the lattice rectum. Parabola here given is RHS parabola. And what is the lattice rectum? Have you seen it in class 11? It is a line segment perpendicular to the axis and passing through the focus. What is the focus for it? For this, it is y square is equal to 4ax. Therefore, a is 2. Therefore, lattice rectum passes through 2, 0. This is the diagram for it. We are having the area in the above the x-axis and below the x-axis. Therefore, area is 2 times 0 to 2 square root of 8x into dx, because y is equal to root 8x. Normal integration. Root x is 2 by 3 whole power 3 by 2. I am substituting x is equal to 2. 2 power 3 by 2 is 2 root 2. Final answer 32 by 3 square units. Let us look at the diagram once again. This is the area bounded by the parabola and the lattice rectum. Move on to question number 6. Solve the differential equation given that y is equal to 1 when x is equal to 1. Before you start, let us find out which type of differential equation it is. By looking at it, I am seeing that I am having x square term, y square term, xy term. Therefore, the powers of all of them are equal. Therefore, this is homogeneous. Remember, in homogeneous, if x square term is available, y square should be there and xy should be there. Then only it is homogeneous. You know how to start a homogeneous equation. I am just writing it as dy by dx is equal to what? So that the cancellations and variable separable will be easy for me. I am putting y is equal to vx. dy by dx is v plus x into dv by dx. Put the substitution. On the right hand side, I am replacing y by vx. Y square by v square x square. Now you can note down the speciality. After this substitution, on the right hand side, x should get cancelled. Therefore, you are getting no x on the right hand side. Be careful. If it is not getting cancelled, either you are wrong or it is not homogeneous. Where x square is getting cancelled. Now all of you know, for variable separable, push that v to the right hand side, take LCM and make it ready. Now the left hand side is x into dv by dx, right hand side is minus of v square plus 1 by 2v. And now variable separable, dx by x will go to the right hand side. Always in these types of problem, dx by x will be on the right hand side. It is always convenient, if there is a minus sign, keep the minus sign on the right hand side. It is always convenient. These are the two things which you have to remember. Number 1, in homogeneous equation, when I substitute right hand side, x will get cancelled. When I do the variable separable, right hand side will become dx by x. Well, now we would have to do integration. Left hand side integration is very simple. Numerator contains differentiation of the denominator. Therefore, it is log of 1 plus v square. Right hand side dx by x is log x. Now in these types of problem, you can take c as log c also. Otherwise, you can take c also. There is no issue. For now, I am replacing v by y square by x square. Now I got the answer. But now suppose if this problem is a boundary value problem. That is, if values of x and y are given, they are given to evaluate c. In this case, once again I repeat, c can be taken as log c for convenience. Otherwise, you can take it as c also. Now I am putting x is equal to 1 and y is equal to 1. Left hand side it is log 2. Therefore, it is log 2 is equal to 0 plus c, because log 1 is 0. Therefore, c is log 2. Put once again in the general solution, you will get the particular solution. Go to question number 7. X square minus 1 into dy by dx plus 2xy is equal to 1 by x square minus 1. Here, some of you may think that this is once again it is a homogeneous, because x square is there, then xy is there, but y square is not there. And one more thing, for linear differential equation, you will get either y, no other terms other than y. If there is x, there is no other term other than x. Here y is there, no term other than y. There is no y square, no log y, nothing. Therefore, this is a linear differential equation. But the coefficient of dy by dx should be 1. I am dividing. Now, I got perfectly dy by dx plus py is equal to q. Therefore, what is p? Dx upon x square minus 1, coefficient of y. What is q? 1 by x square minus 1 the whole square. That is the right hand side. Let us find the integrating factor. E power integral dx upon x square minus 1 dx. All of you know, numerator contains differentiation of the denominator, log of the denominator. E power log, you will get back the same thing. Therefore, x square minus 1. Integrating factor is x square minus 1. We got integrating factor, we got q. What is the formula for solution? The general solution is y into integrating factor is integral of q into integrating factor into dx plus c. Put it now. X square minus 1 getting cancelled on the right hand side. Once again you got 1 by x square minus 1. We are having a formula half log x minus 1 by x plus 1 plus c. Check out, if you have given boundary values, we have to evaluate c. But not given, therefore we are leaving the problem as it is. Go to question number 8. Solve 1 plus e power 2x dy plus 1 plus y square e power x dx is equal to 0. Once again we have to check whether this problem, can it come in homogeneous? No. Can it come in linear? No. Therefore, only option left out with us is this problem should come under variable separable. Let us do. For this, always better to keep dy in left hand side and dx on the right hand side. Now pull and push. I have pulled and pushed dy with all y function with dy and all x function with dx. Well, now I can integrate both sides now. This is the integration. Let us go back to integration of this now. There is no problem with the left hand side integration, but right hand side integration you have to be careful. E power x by 1 plus e power 2x. That can be written as 1 plus e power x the whole square. Now I am substituting. The right hand side will become du upon 1 plus u square. Very simple. Left hand side is tan inverse y. Right hand side is minus tan inverse u plus c. And in this problem, you have been given the boundary values. Therefore, I have to make use of them. When x is equal to 0, y is equal to 1. Therefore, I am putting x is equal to 0 and y is equal to 1. I am getting the answer for c is 2 tan inverse 1, that is 2 into pi by 4 pi by 2. Therefore, put this value in the above general solution to get the particular solution. Tan inverse y plus tan inverse e power x is equal to pi by 2. Move on to question number 9. Assertion. The area of the region enclosed by the curve y is equal to x cube and the lines y is equal to 8 and x is equal to 0 is 12. Once again, what is that y is equal to x cube? It is a curve, all of you know, we can just draw it. Y is equal to 8 is a line parallel to the x axis. X is equal to 0 is the y axis. Therefore, this is the diagram. We are getting on the right hand side. This is the diagram for it. Now all of you know how to do it. This integral is enclosed between y is equal to x cube, y is equal to 8 on the y axis. Therefore, this is the formula. 0 to 8 x dy. 0 to 8 x dy. Let us do it very quickly. Y power 1 by 3. 3 by 4 into y power 4 by 3 from 0 to 8. You know what is the formula for 8 power 4 by 3? It is 2 power 4. Therefore, the answer is 12. It is perfectly given there. Therefore, assertion is true. Please consider this problem can be asked for 2 marks directly also. If this finding the area enclosed can be asked in 2 marks. Well, the area of the region bounded by the curve y is equal to f of x axis on the line x is equal to a, y is equal to b is given by. Reason is perfect. It is true. But remember, this reason is not used for assertion. For assertion, it is y-axis problem. Therefore, both A and R are true, but R is not the correct explanation of A. Once again, let us have a close look at the area enclosed. Y is equal to x cube. Line y is equal to 8 on the y-axis. Let us go to question number 10. Assertion. Integrating factor of the differential equation is. This is a differential equation, linear differential equation of the type number 2, that is dx by dy plus py ry is equal to s, where r and s are functions of y. What will be the integrating factor? R is tan y and s is secant square y, both are functions of y. Integrating factor is e power integral r dy. I am doing it now. E power log secant y, which is secant y. It is given already there, it is secant y. Therefore, assertion is true. What is the reason given? For linear differential equation dx by dy plus ry is equal to s, where and r are functions of y, integrating factor is e power integral r dy. Perfect. It is also true. Sometimes in some questions what really happening is, the reason given always will help you to do the calculations or do the working of assertion. Over here it happened actually. Therefore, both reason and assertion is true. Reason is used by us to prove the assertion. Therefore, both A and R are true, and R is the correct explanation of A. Thank you, friends, and success is dependent on the efforts. All the best.